Manchester Airport is the third largest airport in the UK. We have 2 runways, 3 terminals, handling over 23 million passengers a year. So there could be a variety of issues that we deal with. So I got involved with the airport's optimisation project through the Engineering and Physical Sciences Research Council Sandpit. We talked about the issues that we have, and we set them the task of coming up with identifying solutions.
Taxiing is important because it links together the other problems at an airport. So you have the order in which aircraft take off and land, you have where they go at the terminal building, the gates, and taxiing links these two things together.
The ground movement is particularly important because if you can get a better prediction of taxi times, you can better predict when aircraft are going to arrive at the runway. Because of that, you can actually hold them on stands for a bit longer. If you can hold them on stands for a bit longer, you can start their engines a bit later, which actually gets you much better pollution benefits as well as financial cost benefits because you burn less fuel.
We need to try and solve the problem using optimisation techniques. Understandably, airports are reluctant to share their data with just anybody. I started looking for ways to try and get data about taxiing at a whole bunch of different airports with different characteristics around the world.
One of the things cloud computing does is it brings the power and the data processing ability of huge machines to any researcher's desk.
I'm really positive about Azure. I think it's a great platform. What it gave me access to was a scalable, powerful machine that I could use to do the job that I wanted. Part of this project, I have written 3 open source tools that are available on GitHub. They are SnapTrax, TaxiGen and GM to KML, and these all take care of different aspects of processing data connected with airport ground movement or taxiing. I was pleasantly surprised by how simple it was to use open source tools with Azure. Linux, OpenJDK, SSH all worked just straight away very easily.
The computing power that we've got now has allowed us to analyse data in different ways and to pull out different pieces of information so we can actually understand a lot better the true uncertainty in taxiing, so we can understand which aircraft take a long time to get there, which aircraft get there very quickly, and we can understand under what circumstances this is happening, which means we can optimise the system as a whole. As passengers, we have all experienced various delays at airports, and if those delays can be reduced by more efficient operations, obviously that benefits us all.
Azure really made this research possible in a reasonable time frame. I had quite a big amount of data that I wanted to be able to get through, and I was able to process it in something like 1/10 the time that I would have done on my desktop. So rather than spending several months waiting for my data to be ready, I had it within a couple of weeks.
Aviation is an industry that's growing, so there are lots of ways that the industry is trying to tackle the impact that that growth could bring to the climate. So the airport optimisation project feeds into that because we want to reduce the amount of CO2 that's generated when an aircraft lands, taxis and ultimately departs from the airport. The airport optimisation project is going to be really important to make sure that we maintain the efficiency, safety and passenger experience.